The morning of May 18, 1980, dawned like any other in the Pacific Northwest. The air was crisp, the sky clear, and the forest teeming with life. Birds chirped their morning songs, and the gentle rustling of leaves created a serene backdrop. But high above the treetops, Mount St. Helens was about to unleash a spectacle of unimaginable force. The mountain, a majestic and seemingly tranquil giant, had been showing signs of unrest for months. Small earthquakes and steam venting had hinted at the brewing turmoil beneath its surface. At 8:32 a.m., a magnitude 5.1 earthquake ripped through the mountain, triggering the largest landslide in recorded history. The north face of the mountain collapsed in a massive rock slide, releasing pent-up pressure in a cataclysmic explosion. The landslide unleashed a pressure wave that flattened forests for miles. Trees, some over 100 feet tall, were snapped like toothpicks and laid to waste in an instant. The sheer force of the blast was beyond comprehension, leaving a trail of destruction in its wake. Hot gas and ash erupted sideways in a scorching blast, reaching speeds of up to 650 miles per hour. This pyroclastic flow, a deadly mix of volcanic gas, ash, and debris, incinerated everything in its path. The heat was so intense that it melted snow and ice, creating devastating mud flows known as lahars. The eruption column soared 80,000 feet into the sky, darkening the day and depositing ash across a dozen states. The ash cloud traveled across the country, affecting air travel and causing respiratory issues for people hundreds of miles away. The sky turned an eerie shade of gray, and the sun was blotted out, casting a shadow over the land. The landscape was forever altered. What was once a vibrant ecosystem teeming with life was now a barren wasteland. The eruption had stripped the land of its vegetation, leaving behind a desolate and unrecognizable terrain. Lush valleys transformed into desolate wastelands, rivers were choked with ash and debris, and the once clear waters turned murky and lifeless. The impact on the environment was profound, with entire habitats wiped out in a matter of minutes. The once conical peak of Mount St. Helens was replaced with a gaping horseshoe-shaped crater. The mountain had lost over 1,000 feet of its height, and the new crater was a stark reminder of the eruption's power. The landscape around the crater was a chaotic mix of jagged rocks and volcanic debris. It was a stark reminder of the raw power slumbering beneath our feet. The eruption of Mount St. Helens was a wake-up call, a reminder that nature's fury can strike without warning. It reshaped the land and left an indelible mark on the history of the Pacific Northwest. The event stands as a testament to the dynamic and ever-changing nature of our planet. Mount St. Helens is a stratovolcano, a towering cone built up over millennia by layers of lava and ash. This majestic peak stands as a testament to the powerful forces of nature that have shaped our planet over countless ages. It's part of the Cascade Volcanic Arc, a chain of volcanoes fueled by the collision of tectonic plates off the coast of North America. This arc stretches from Northern California all the way up to British Columbia, forming a fiery necklace of volcanic peaks. This process, called subduction, forces the denser oceanic plate beneath the continental plate. As these massive slabs of the Earth's crust grind against each other, they generate immense heat and pressure. The immense heat and pressure melt rock, creating magma that rises to the surface, erupting as volcanoes. This molten rock, or magma, finds its way through cracks and fissures, eventually bursting forth in a spectacular display of nature's raw power. Mount St. Helens has been active for at least 40,000 years, with periods of intense activity interspersed with centuries of quietude. These cycles of dormancy and eruption have sculpted the mountain into its current form, each eruption adding new layers to its complex structure. The 1980 eruption, though devastating, was a relatively small eruption for this fiery giant. On May 18, 1980, the mountain unleashed a massive lateral blast, sending ash and debris skyward and reshaping the surrounding landscape in an instant. Geological records reveal a history of even more powerful eruptions, shaping the landscape we see today. Core samples taken from the mountain's flanks tell a story of repeated, cataclysmic events, each one leaving its mark on the terrain. These samples provide invaluable insights into the mountain's past, helping scientists predict future activity and understand the dynamic processes at work beneath the surface. Today, Mount St. Helens is closely monitored by volcanologists and geologists who study its every tremor and gas emission. Their work is crucial in predicting future eruptions and mitigating the risks posed to nearby communities. The mountain remains a living laboratory, offering a unique window into the inner workings of our planet. Despite its violent past, Mount St. Helens is also a place of renewal and rebirth. The landscape, once devastated by the 1980 eruption, has gradually come back to life. Plants and animals have returned, and the area has become a popular destination for hikers and nature enthusiasts. The mountain stands as a symbol of nature's resilience and the ever-changing face of our Earth. As the sun sets over Mount St. Helens, casting a golden glow on its rugged slopes, we are reminded of the powerful forces that continue to shape our world. This iconic volcano, with its storied past and uncertain future, remains a testament to the dynamic and ever-evolving nature of our planet. From the snow-capped peaks of Wyoming, where the serene beauty of nature is on full display, to the geyser basins of Yellowstone National Park, where the Earth's geothermal energy bursts forth in spectacular displays, a different kind of volcanic giant slumbers beneath the surface, hidden from plain sight but ever present. Yellowstone is not just a single volcano but a supervolcano, a massive caldera formed by eruptions that dwarf any volcanic activity we have seen in recent history. These eruptions are thousands of times larger than the eruption of Mount St. Helens, which itself was a monumental event. Beneath Yellowstone lies a colossal reservoir of molten rock, a magma chamber that is one of the largest known on Earth. This magma chamber is heated by a plume of intensely hot material rising from deep within the Earth's mantle, a process that has been ongoing for millions of years. This plume acts like a superheated jet within the Earth's interior, continuously feeding the magma chamber and maintaining its potential for future eruptions. Over the past 2.1 million years, this plume has fueled 3 cataclysmic eruptions, each one reshaping the landscape and altering the course of life on Earth. These eruptions ejected thousands of cubic kilometers of ash and rock, creating ash clouds that spread across vast areas of North America. The ash blanketed the continent, impacting the global climate and causing dramatic shifts in weather patterns and ecosystems. Today, scientists closely monitor Yellowstone for any signs of activity. Although it is not currently showing signs of an imminent eruption, the potential for future activity remains. The immense power of Yellowstone's supervolcano demands our attention and respect. It serves as a reminder of the dynamic and ever-changing nature of our planet, a force that can shape the world in ways we can scarcely imagine. Despite its potential for destruction, Yellowstone also offers incredible beauty and wonder, attracting millions of visitors each year who come to witness its geysers, hot springs, and stunning landscapes. The geothermal features of Yellowstone, from its bubbling hot springs to its colorful mineral deposits, are a testament to the powerful forces at work beneath the surface. The park is also home to a diverse array of wildlife including bison, elk, and bears, all of which thrive in this unique and dynamic environment. As the sun sets over Yellowstone, it casts a golden glow over the landscape, a tranquil end to a day in one of the most geologically active places on Earth. At night, the stars twinkle above Yellowstone, a reminder of the vastness of the universe and the small but significant role our planet plays within it. Yellowstone's supervolcano may be silent for now, but its presence is a powerful reminder of the forces that shape our world, forces that we must continue to study and respect. The sheer power of volcanoes like Yellowstone is truly awe-inspiring. This leads to a natural question. Could one eruption trigger another nearby? Could the rumblings of Mount St. Helens, for instance, awaken the sleeping giant beneath Yellowstone? The answer, thankfully, is no, it cannot. While earthquakes can indeed trigger volcanic eruptions, the distances and geological mechanisms involved make it highly unlikely to happen. Think of it like dropping a pebble in a calm pond. The ripples might reach the other side of the pond, but they won't be strong enough to disturb a large rock resting on the bottom of the pond. Similarly, the seismic waves from an eruption at Mount St. Helens would dissipate long before reaching Yellowstone. And even if they did, they wouldn't have the energy to trigger an eruption in this massive independent volcanic system.